இருக்குல்ல. இப்போ அந்த ஃபோட்டோஸு இந்த இன்ஸ்ட்ரக்ஷன் போட்டு விட்றேன். ஃபோட்டோஸ் போட்டு திடீர்னு நான் அனுப்புகிறேன். இரு உனக்கு வாட்ஸ்அப்பில். பைசல் ஒரே நிமிஷம் நான் இதில் எங்கன்னா இதில் இருக்கான்னு பாரு. டெலிட்டேட்டில். சரி போட்டு விடு. இதே போடு போடு. போடு. இல்லைன்னா விட்டுடு, பரவாயில்ல. இது வரைக்கும் லைவ் பண்ணால் கூட போதும். விட்டுரு பரவாயில்ல. நான் செக் பண்ணிடுறேன் ஒரு தடவை யூடியூப்ல. வரலையே ஏன்பா? யூடியூப் வரலையே. வரலப்பா. பைசல் வந்துருச்சு. பைசல் வந்துருச்சு. அந்த ஃபோட்டோ வைக்க முடியாதா? வரலையே. ஃபோட்டோ வரலையே. ஃபோட்டோ வரல. நம்ம ஸ்க்ரீன் தான் வருது. பார்ட்டிசிபென்ட்ஸ் வந்திருக்காங்களே உள்ள, அதுதான் வருது. இல்லை விட்டுடலாமா? ரிஸ்க் எடுக்க வேணாவா? சார் இது லைவ் போட்டாச்சு. ஆன்ல இருக்கு, போயின்னு இருக்கு. இப்போ இல்லை, இப்போ ஆஃப் ஆயிடுச்சு. டீன் இருக்கிறது தானே உங்களுது. அதில் தான் இப்போ மேம் வந்து நின்று சாப்பிட்றாங்க ஜம்முன்னு. இப்போ தான் டிஃபன் செஞ்சீங்களா? செஞ்சாங்களா? இல்லை இல்லை, லேப்டாப்பில் இருக்கிற கேமராவில் வரும். ஆமாம், நீங்கள் அதை யூஸ் பண்ணுறீங்கல்ல, அதனால் அதை நீங்கள் ஆஃப் பண்ண முடியாது. ஓகே ஓகே. ஃபைசல் இப்போ லைவ் போது விட்டுடலாமா? வேற எதுவும் ஒர்க் இல்லைல்ல? இப்போ யூடியூப் போர்டு இது வைக்க முடியல போர்டு. எங்க யாரு ஸ்பீக்கரோ அவங்களுது அதானே சொல்றேன். இவங்க இல்லை, இவங்க தான் ஹெச்ஓடி. இவங்க தான் ஹெச்ஓடி. பேச போகிறது அனுராதான்றவங்க. இப்போ லைவ் போயின்னு இருக்கு. அவங்க இங்கே யார் பேச வராங்களோ அவங்களோடது ப்ரெஸ் பண்ணால் போதில்ல. ரைட், ஓகே, நான் பார்த்துக்கிறேன். ஏன்னா டவுட்னா நான் ஃபோன் பண்ணட்டுமா? இது அட்டன் பண்ணுறியா உடனே? சாப்பிட்டியா? சரி, இப்போ இப்போ லைவ் போயின்னு இருக்கு. இப்போ அவங்க வந்த உடனே அவங்கள நான் அந்த வீடியோ இது மட்டும் கிளிக் பண்ணணும். ப்ரெசன்டேஷனை மட்டும் 2 வரும் இல்லையா அவங்களுக்கு? 2 வரும். அனுராதா ப்ரெசன்டேஷனுக்கு பின் பண்ணால் போதும். ரைட்டா? ரைட், ஓகே, தேங்க்யூ. இந்த 11 o'clock இது ஆரம்பிச்சு விட்டுட்டு நான் வந்துடுறேன். 11 o'clock நம்மளதை பார்த்துக்கலாம். கொஞ்சம் ரெடி பண்ணு. இல்லா கூட பேசு. எது மாதிரி காட்டுச்சுன்னா நம்மளுக்கு என்ன இது? நம்ம ஆன் பண்ண ஆஃப் பண்ணக்கூடாதுல்ல சிஸ்டத்தை. நம்ம தாராளமா நீ ஃபுல்லாவே இரு ராஜா. உனக்கு எதுனா வேலை இருக்காதுன்னா நான் கேட்டேன். இருந்தா எங்களுக்குன்னா நல்ல தானப்பா.
Hello, ma'am.
சார் இந்த ஃபேன் இருக்கு.
हेलो
Sì, 50 नाटक ଅଛି ଗୁରୁ।
Shall we start?
ஏய் குழந்தையோ
Who's an off? Please start. Shall we start?
Ma'am, presenter is ready, ma'am. Hello?
Anuradha, ma'am. Shall we start, ma'am?
Ma'am is ready, means we start, ma'am.
As in, ma'am.
Sir, hello, sir. Hello, sir.
என்ன ஆரம்பிக்கல இன்னும் அவங்க
மேம் வந்து ரெடியாக தான் இருக்கேன்.
இல்லை ரெடி ஆகிட்டாங்களே அனுராதா அது பாருங்க ப்ரெசன்டேஷன்லேயே வந்துட்டாங்களே அவங்க
வந்துட்டு நான் பின் பண்ணிட்டேன் சார் உங்களுக்கு.
அவங்க ப்ரெசன்டேஷன் ஸ்டார்டட். இவங்க ஏன் இன்னும் பண்ணாத இருக்காங்க?
இல்லை அவங்க ரெடின்னா அவங்க பேசல சார்.
இதை பாருங்க அனுராதா ஜி ப்ரெசன்டேஷன் வந்து அவங்க பண்ணிட்டாங்க, அவங்க ஆரம்பிச்சிட்டாங்க.
அப்படியா சார்?
நான் அவங்களுக்கு ஒரு அதை பாருங்க அவங்க லைனில் தான் இருக்கிறாங்க. நான் ஃபோன் பண்ண சொன்னேன், அதுக்கு தான் அவங்கள அதுக்கு தான் ஆண்ட்ராய்ட் ஃபோனுக்கு வந்து அவங்களுக்கு ஒரு 5 நிமிஷம் முன்னாடி ஃபோன் பண்ணிட்டோம்னா அவங்க
பண்ணியிருக்கேன் சார்.
பண்ணியிருக்கீங்க நீங்க, அவங்க எடுக்கல.
ஆனால் அவங்க வரல.
என்ன பண்ணுறாங்க?
இல்லை மேடம் வந்து
யாரோ பாபுன்றவனெல்லாம் நீங்கள் கேமரா விட்டுருங்க, வாய்ஸ் மட்டும் நான் கூட இங்கே பார்த்துனே தான் அதை ஆஃப் பண்ணிருந்தேன். அது ஒன்றும் பிரச்சனை
மேடமோட ஸ்க்ரீன்
பின்னால இல்லை, இதாக இருக்கு. பின் பண்ணல அவங்க.
இப்போ வந்து அவங்க ஸ்க்ரீன் வந்து
இதோ இப்போ வந்திருக்கு, இப்போதான். வராங்க. நீங்க வந்துட்டீங்க.
Shall we start, ma'am? Ma'am,
Yes.
What about the discussion, ma'am? Ma'am,
Anuradha, ma'am.
Are you ready, ma'am?
ஏன் ஆரம்பிக்கல? இன்னும் ஆரம்பிங்க. அவங்களும் வந்துட்டாங்க, லைன்ல இருக்காங்க, பிரசன்டேஷன்ல இருக்காங்க அவங்க. வரைக்குமே 22 நிமிஷம் ஓடிட்டு இருக்குது. இது வரைக்குமே 22 நிமிஷம் ஓடிட்டு இருக்குது. இன்னும் அந்த அம்மா வரலையா? பாரு மீட்ல பாரு, மீட் இன்னும் வரல போல இருக்குல்ல. நான் அனுப்புறேன் மெசேஜ். ஒரே நிமிஷம். வைஜல், ஒரு மெசேஜ் அந்த அம்மா அனுராதா அனுப்பிச்சிருக்காங்க. அது என்னன்னு பாரு. உனக்கு அனுப்பிச்சிருக்கேன் பாரு.
Ma'am, Anuradha ma'am, you can start ma'am.
சரவணன் சார்.
Hello,
சரவணன் சார்.
ma'am, Anuradha ma'am, you can start ma'am.
சரவணன்
Ma'am, can you hear me? Anuradha ma'am.
மேம் சொல். இல்லை மேம், நீங்கள் வந்து இது கிளிக் பண்ணல. இன்னும் மைக்கு வந்து ஆஃப் பண்ணியிருக்கீங்க. ப்ளஸ் ப்ரெசண்ட்டில் வந்து ஸ்லைட் ஷோ பண்ணணும். அந்த கீழே இந்த கப்பு yeah, we are able to see your screen, everything. Only thing is, I think we are you have to start and அது பண்ணுங்க. One thing, you are presenting now, right? So your camera visible. You do it again. You do one thing, ma'am. You open the PPT first and minimize it. Then you do it. You are right. Then present now. A window. Let it be, no problem. You are the only person. No time you will get into it. Please, wait. Yeah. Okay, I will do one thing, otherwise I will ask somebody to leave, right? I will just a minute, just a minute. சரவணன் எடுக்க மாட்டேன்றாரு. என்ன ப்ராப்ளம்னு சொல்லிட்டு கண்டுபிடிச்சிட்டாங்க. அவங்களே ஒரு நம்ம வீட்டில் 3 பேர் பார்த்துட்டு இருந்தீங்கன்னா 2 பேர் கட் பண்ணுங்க. இந்த இவெல்லாம் இருக்கா பாருங்க, சூசன்லாம் இருக்கா பாருங்க, கட் பண்ணுங்க. 100 பேருக்கு மேலே போயிடுச்சு, சப்போர்ட் பண்ண மாட்டேங்குது சிஸ்டம். அவங்களுக்கு அதான் மெசேஜ் அவங்களுக்கு போகுது. அவங்க சார் 2 பேரையும் கட் பண்ணுங்க. சரவணன் ஃபோனே எடுக்க மாட்டாரு, ஸ்டாப் பண்ண சொல்லுங்க அட்மிஷனை. யூடியூப்ல பார்த்துருக்கேன். வா இப்போ வந்துடுவாங்க, கரெக்டாக வந்துடுவாங்க. 99 பேர் இருக்காங்க. சார் அப்டேட் பண்ணாதீங்க சார், 100 பேர் எக்ஸீட் ஆகிடுச்சா, அது அவங்களுக்கு வரமாட்டேங்குது. நம்ம வீட்டில் வந்து மேம் ஒய்ஃப் எதனா ஆன் பண்ணிருந்தாங்கன்னா ஸ்டாப் பண்ணிடுங்களா? ஏன்னா இதில் 100 இருக்கு, 98 இருக்கணும். ஆ
Yeah, we can start, ma'am.
Can you hear me? Hello.
Yes, ma'am, we are able to hear you. Please.
Oh, okay,
Ma'am,
okay,
start,
sir.
ma'am.
So, is my screen
Yeah.
is my screen visible, sir?
No. You have to present it. Yeah.
Yeah. I'll do that. I'll
It
do
is
that.
visible. It is visible. It is visible.
Okay.
You make
Now,
it.
okay.
You make it slideshow.
Yes, sure.
Screen is visible.
Screen. Yeah. Everything is fine. Now we can start.
Yes. So, very good morning to all of you. It is a pleasure of mine to take this opportunity, and here I am going to.
இவ்வளோ நேரம் ஆச்சு அவங்களுக்கு.
So now, coming to this, the contents for the today's delivery. So first will be the introduction to machine learning, followed by some of the applications or the domains where we use machine learning, and how machine learning is being applied in our day-to-day life, and the comparison, a small comparison, though I am not going to deal in detail about deep learning, but still let us just have a brief on deep learning and how this deep learning is different from machine learning, and some models, machine learning models in the view of supervised learning, unsupervised learning. If time permits, I can give the demo on the models what we discuss here. Now, coming to the machine learning was the field that was introduced long back in the year 1959 by Arthur Samuel. So he is an American who worked for IBM. He is an electrical engineer who has first developed a game programming for chess, and he is the one who has done alpha beta pruning for the game theory, and he along with the American who worked for yes, and he along with the Donald Knuth. You would have heard this name, Donald Knuth. So he is a professor who has written book on algorithms. So Arthur and Donald Knuth together have developed a text
Hello.
typesetting.
Excuse me.
Hello, yes.
Ma'am, we can't see your PPT actually.
Oh, is it?
Yeah.
Ma'am, please, you go ahead, ma'am. It is visible.
No, is this PPT is not visible?
Yes, it
No.
is visible. Maybe problem with your speed. You Please go ahead.
Actually, it is shown on a small screen. We can't see it big.
Ma'am, one thing, please, you don't answer to any participants. We will take care of them. You go ahead with your talk.
So now my screen is visible now, sir?
Yes, yes.
That is what.
Visible. Perfect.
Yeah.
No problem.
Yes, thank you. Thank you. Thank you. So now, Professor Arthur, along with Donald Knuth, has developed a text where these days we have used this text for typing math equations and all those. So they have developed that. So what I mean is he is the forerunner for this field, and he has introduced machine learning and game programming in the field of artificial intelligence. When I coined the term artificial intelligence, now what is ML and what is artificial intelligence, and what is the difference between these two? So coming to this, artificial intelligence, AI is a big, very vast field which includes many subdomains like machine learning, robotics, statistics, game theory, computer vision. Many such subfields are included in this artificial intelligence, where machine learning is one subfield in the umbrella of AI. Now, coming to machine learning, so how this machine learning behaves, it is about designing and development of algorithm. That means we try to model a program that allows computer to gain intelligence by evolving behaviors based on the empirical data. So the data what we provide to the system, it tries to analyze those data, understands this data, and views the data in the different dimensions and provides us the inferences out of it or the knowledge out of it. In short, we could say it provides an intelligence to machines to understand or respond to the environment or to the application. Now, machine learning model built a mathematical model on machine learning written by Tom Mitchell in the year 1997, and this is a Tata McGraw-Hill book, publishers, and this is the fundamental book on machine learning. So those who are new to the field of machine learning, want to start from the scratch, can definitely refer this book. This is a very good book that gives the complete detailed understanding of machine learning from the scratch. Again, the author is Tom Mitchell. The second book, it is as equal important as this book, Tom Mitchell. This is on pattern recognition or pattern classification, which talks in the aspect of mathematical modeling, how we need to model the machine learning algorithms, on what mathematical background we are going to model it, and how the model visualizes the pattern or try to understand the pattern. So that is given by this book, the Duda Hart, Richard O. Duda, Peter Hart, and David Storr. So that is, the book name is Pattern Recognition. It's by the Wiley publishers. These books are the very basic book on this field. Now coming to the machine learning, so we know that what machine learning is. To brief out, machine learning helps to understand the data what we provide through a mathematical model. For this, we will be writing a program to model this to understand from the data. So now, where and all this machine learning can be applied? Machine learning can be applied in various fields, numerous fields I could say, and few I have listed here. So the first one is route, the best route and best way of utilizing the resources in the network. The next one is on the security domain, how to detect the intruders, what is the pattern of the intruders, and the next field is game theory, how to play the game, automated game. There's few examples are chess and Mario game. And few other are automated parcel sorting. So one by the company Alibaba, and Amazon cashless shopping store, that is Amazon Go, which is located in Seattle, America. Amazon Alexa and Google Home, you would have viewed this, seen this picture in Amazon. Somebody would have even bought this. It will be an assistant for you. It will give you the response for all of your queries, and it could be your personal assistant for you. So automated taxi driver photo tagging and spam detection. So spam detection is not new for you when you open your email. So apart from the inbox, there are many other folders. One such folder is this spam folder. So we don't explicitly categorize the emails that it is a valid email or it's an invalid email or a junk email. So your mail application automatically detects that it is a junk email and puts to a spam folder. How does it do? So it does based on this machine learning application, machine learning model. And some other applications or web search, you are searching on the web on day-to-day basis, how smartly it gives the response for our search. Computational biology, which is in terms of genomes, DNA, and then drug prediction and all those. In the domain of finance, the prediction of the market, how it will be in the near future, how the trend is, all those. Then e-commerce site. There are many examples on this e-commerce site. I will give you later. Space exploration, robotics, information extraction, social networks, what you use in your WhatsApp, and speech recognition. These days we are giving our query through voice in our Google search, right? So here this voice recognition should understand what is your query, irrespective of the slang what you use, and irrespective of the influence of the geographical influence in your English. Irrespective of that, it could recognize the words properly and perform searching. So that is one such application on speech recognition. And the next one is video analytics. These are few. And here you could see the images of the drone that is used for delivering the medicines and food. So you would have seen this application, this drones. I could say it's an intelligent drone, which was used during the flood at Kerala, Tamil Nadu, and then West Bengal. Right, drones that are used to deliver those things in a remote places or disconnected places. So before I proceed for this, I would like to show some videos before I start here. Sir, is my video visible?
Yes. No, you are yet to play, ma'am.
Sir,
Ma'am.
is my video visible? Video?
Ma'am, visible.
Visible. Okay. So I'm playing a video here. So this is about the robots that delivers the package. This is in the Alibaba company. That's a parcel delivery company. That's an e-commerce company, I could say. So it sorts the packets. Coming to this, the inquisitive of this application, that is automated parcel delivery. So it is like those are the robots that moves across the places and takes the parcel and put it into the respective slots properly, and they don't clash each other. They identify what is the parcel and where it has to deliver to and put it into the respective slots. So how these robots could behave properly without any chaos. So that is the curiosity. All behind this is the machine learning or AI technology. So robots and machine learning. So because of this, it is possible that it could deliver sort at least 18,000 parcel per hour. Can you ever imagine what a human can do per hour? See how it minimizes the task of the parcel sorting. Now, continuing to our applications, the applications in our day-to-day life. And during this lockdown period, so we have heard much about this automated systems in the trends of the COVID, at various countries, how it is infected, what is the trend, the infectious trend, and we are all curious to know when this trend will go down. I mean, the infection goes down. So you could have visualized this sort of some graphs. So with lot of dots with the light to darker shades that represents the infected persons of COVID. And this is again the analysis that is done based on the machine learning model. And here the top one is the robot that assists a patient affected by the COVID. Basically any infectious person where the humans find difficult to handle those patients. So robots can do a better job than human in such scenario. So these robots are even being used in the hotels and then hospitals, and where we have observed that these robots move very smoothly without colliding with each other, and move to the correct person to deliver the content, had it been a food or a medicine. So all behind this is machine learning. And the lower one, what you observe is the chest X-ray. So that is taken from the COVID patient. From this, one can understand that how much he is infected and how worst the infection is. So just to with the chest X-ray, one can recognize this. So we need a machine learning model to understand what is this chest X-ray and what does this data convey. Okay. So these are some other machine learning applications that we use in our day-to-day life. The one is this photo sketching. So this you would have used in your some applications in your mobile. And this is the collage that is created out of hundreds of thousands photographs to make into one image. So that is using this computer vision. So this blurring of the image, yes, you would have used in your mobile phones, applications in the mobile phone. And this is again another interesting applications, which is a very trending applications that is applied in using deep learning model, where it could recognizes the objects, had it been a human or car or a signboard or a building or whatever. And it even goes one step beyond this to give response to the queries if asked based on this image. So the algorithm or the model is developed so much that it even could give the response for the queries that is asked from this image. And the next one is hand gesture recognition. The other might be the gait recognition. The gait recognition is the position when you run, when you jog, when you jump. So it could recognize this position, especially it is used in the field of IoT. So what is the behavior of the person, to predict what is the behavior or what could be the next movement of the person, that one can predict. And the next application is vehicle counting and classification. What is this, each one of this vehicle is, and what type of vehicle is, how many number of vehicles process at a point of time in a toll or at a given place. So that can be done. And even one step beyond this, one can even predict the speed of the vehicle using the video, captured video from that lane. So that is also possible. So another one in the domain of security. So as I mentioned you earlier, so this machine learning is used to understand or used to watch the data, in and out flow of data, and why there is a significant difference in the flow of data, and it captures who causes that that massive data flow, and by this way one can capture the intruder And not only that, what is the style of attack? What is the style of attack? So that can be identified. And there are many applications in mobile phones. You can even categorize the application, whether the applications are secured or insecure applications. Many would have installed such type of application in your mobile to make yourself secure to access the applications through mobile. So here it understands what sort of data that each of these apps are utilizing from your phone. So by understanding that, it categorizes whether it is a safety application or not safe application. So the next one is the spam detection. So here are two spam emails that was given. So both of these are related to bank. So here it says that please click the above link to our website and confirm or update your account of information. And here the same way it is. So someone, some unknown may have access to your account. As a safety measure, please visit our website via the link below to verify your personal information. So the signature or the nature of this data, the pattern is the same. The pattern of the email is the same. That means they want to click the email and share your credentials. So by this way, it understands that these mails are spam mails. So it automatically put those mails to the spam folder. So this spam classification is one that uses machine learning, where it automatically detects that mail based on the content, the pattern of the content, and classifies whether it is a spam or not spam. And few from the e-commerce site. So one I have taken from the IRCTC site and one from the Amazon site. So have you ever observed that the ads that you get in your site is more related to the way that you access your content? There is lot of correlation between the ads and the way that you access your content, or the data that you access your content. So it captures the age, it captures what type of data you are accessing, and what is your interest based on the data that you use, or the sites you visit. So accordingly, it maps to the corresponding ads and gives the ad display in your page. And every ad is based on the interest or the type of data that we access on the web page, right? And here, this is another site from Amazon, where see, I was searching for a model of one some airline frock or whatever. So here you would have observed lot of such options were given. Options are given. That means it gives that these are the other models you may like. Okay, so that it gives a lot of varieties and options for you to choose. And this is another page from Amazon. Having chosen one book, so here I can find that there are many other books, okay, on the same written by the same author, or the person who have bought this book has also bought the other two books. So they are also providing a combo offer, so that they make you to buy all these three. Okay, so that is the strategy they are applying. So what I mean to say is here they are providing coupons, they are providing offers, and they are providing suggestions, recommendations based on based on our interest on the data. Okay, so next is particularly on the drones that is used. This is a page taken from the Indian government Indian Space Research Organization, where it uses unmanned aerial vehicle. So when you view this drones as a drones of machine, it is not only the machine that fly. There are a lot of algorithms and intelligent programs that works behind the screen. So those programs helps us to understand, visualize the data, what data it is, and track the data. So detecting the object, also tracking the object. irrespective of the light. It might be a bright daylight or it might be a dark night time light. Irrespective of that, it recognizes the object and tracks the object and understands what could be the next move. And we would have heard stories of attacking the hostile drones or other machines, right? So that is possible. So that is providing intelligence to those drones. And this is one such drone that is used in agriculture for dispensing of fertilizers and other stuff. So having discussed much on the application, just to know the importance of machine learning, where and all machine learning can be applied, to what extent machine learning can be applied. Now, it is highly important now to understand the difference between what is deep learning and machine learning. In most applications, what I've shown before has used deep learning and also few with machine learning. So what is it? So I can say that deep learning is a superset of neural network model in machine learning. So deep learning, or otherwise if you just view as a field of machine learning, deep learning is one subset of machine learning. So what's the difference between deep learning and machine learning? So deep learning can be applied to intensify the learning. So to get more detailed information from the data or from the image, how can we get it? So that is through deep learning models. Machine learning model, of course, can give you the information from the data, but cannot give the detailed information. As like I told you an example in the previous slides of detecting an object and giving the response to the queries given in the image. So such application is not possible using this machine learning. However, machine learning can detect an object, but it cannot give in detail information of what is available in the picture. So that is not possible by the machine learning, but that is possible with the deep learning. So to be very precise, deep learning learns the content in detail. So that is deep learning model. So now I've just differentiated machine learning and deep learning here. So in the aspect of data that is used for training the model and how accurate, what is the time it takes, and what are the hardware requirement and the hyperparameters. So deep learning, to know every detail of the data, definitely we require a large amount of data for a model to understand much better about the data. And whereas in machine learning model, you don't require such a large amount of data. And coming to accuracy, definitely deep learning gives a better accuracy compared to a machine learning models, especially in terms of a larger data. So comparatively, machine learning is less accurate, but it performs well on a smaller data. Training time, since it works on a larger data set, and the model is even more complex than the machine learning model, it takes longer time for training. But comparatively, machine learning model is not complex. It's simple, in other words, and it takes less time. Coming to hardware requirement, so it involves lot of computation, and therefore it requires a GPU to train. Whereas in machine learning model works on the CPU itself, it consumes less time. And hyperparameter, there are too many parameters in the deep learning, hyperparameters, and these hyperparameters can be tuned in various ways, different ways. Whereas in machine learning models, there are parameters, but limited number of parameters. Yes, you can also fine tune those parameters, but it has limited capabilities. So our focus is going to be on the machine learning models only. So hereafter, I'm going to deal with only on the machine learning models. So coming to the machine learning models, So I have classified this based on the learning paradigms or the way in which the machine learning models learn the data. So that can be broadly classified or put it into three broader class. One is on supervised learning, unsupervised learning, another one is on reinforcement learning. So coming to this supervised learning, so they learn from the samples. The sample gives the data and what is the output that the data will or should take. So that will be given. So based on that sample, so it will learn. So for example, I can tell you like in a class, a professor gives lecture, he gives questions. You will be responding to the questions based on the lectures that you have attended, and in the response you may be right or you may be wrong. So the wrong ones are corrected by the professors, and so that your learning gets improved. And that is what is the behavior of the supervised learning is. For unsupervised learning, you have data and all you have to learn by yourself. So there is no guidance for you. So you have to learn by yourself. And that is what is unsupervised learning is. I can tell you like having bought any mobile phone or any other devices, you try to explore what is there in the mobile, what are the apps, what are the security issues, and how can I connect, what are the privileges I should set. And those things you can learn by yourself. You never ask someone to help, but you will learn by yourself. And that is what is unsupervised learning is all about. And the next one is reinforcement learning. Reinforcement learning is like you try to learn, but you get a feedback from the environment. Say suppose you want to reach to your friend's house, so you're going for the first time, so you don't have any information about the area, but you know only the address of your friend. So that means while you're proceeding or going across the street, you will get the feedback from the neighborhood houses or the houses from the lane, whether you are going on the correct path or not. So sometimes when your path is wrong, so you recorrect yourself and then you take another lane, and thereby you proceed further and check yourself whether you are going in the right direction or not. Of course, you have GPRS help these days. So now this is the combination of both supervised learning and unsupervised learning. So you have guidance from the environment in terms of award or penalty. That is the feedback from the environment, and the learning all you have to do by yourself, and you correct it from the feedback, and that is what is reinforcement learning is all about. So I can tell you like while you are solving a maze problem or you are solving a Sudoku game, so you try to find out the solution. Sometimes you may go wrong, and you check whether you're going wrong. Sometimes you get clash, so you recorrect yourself and take another solution and try to explore further. So that is what is reinforcement learning is all about. And this reinforcement learning is used mainly for game theory. So coming to the supervised model, so there are the basic categories are classification and regression. So classification is it tries to label the data, and regression is it tries to give the predict the numerical value. What will be the future trend? What will be the rate of house after 1 year at a given area, or how will be the stock market after 1 year? So what will be the how many number of patients will be affected by COVID after 1 month? So that when your answer is in terms of numerical value, then that is regression. When your answer is in terms of categorical value, that is yes, no, it's a car, it's a bike, then it is a classification. So ensemble classifiers are those it applies more than one model of classification or regressions, and that is what this ensemble classifier is all about. And here there are to name few of classifiers. decision tree, k nearest neighborhood, support vector machine, null-based classification, backpropagation. These are few classification models. And to name few on regression, linear regression, logistic regression, multilinear regression, are few regression model. To name few, an ensemble model, random forest, XG, and then XGB, and then AdaBoost. Those are few ensemble classifiers. So here I'm going to discuss on classification models and ensemble models, not going to focus on regression here because time is very limited, so I cannot touch upon everything within this 2 hours. So here I'm going to touch upon k nearest neighborhood, decision tree in classification, and in the ensemble classifier, random forest, and in the clustering, that is unsupervised model, I'm going to take k-means. Now, coming to unsupervised models. So, unsupervised models, it is unlabeled data. So, there are many unlabeled data where you don't, where the data does not give any information about what the data is and what does it convey. Irrespective of that, in spite of that, so we have to find out or we have to classify those unknown data set, and for that we will be using grouping technique. So we group those data based on the similar characteristics or similar nature of data. So similar behavior, similar characteristics, we group the data. So that is what is k-means, k-medoids, hierarchical clustering, density-based clustering, grid-based clustering, verge clustering, all of these do. And each one of this has its own plus and minus of grouping. So coming to supervised learning model. So learning from the labeled data. So that is, we have data set, and assume that X is the data that has set of attributes, and C is the class label for the attribute. So for example, let us say the data of COVID. So in this COVID, there are certain symptoms like cough, fever, and chest congestion, and the sensitivity to the smell and taste. So those are the symptoms that I can say it as attributes, that is represented as X1. And C1 is the label, that means whether the patient has COVID or not, yes or no. So that is the label, class label. So the data can be of two types, that may have binary labels, yes or no type, or it can have multiple labels like categories of bicycle, car, and truck. And so by this way we can classify this classification model as binary classification model or multi-class classification model. And to train on this data set, so we create a suitable model to train on this data set and evaluate how good or bad the performance of this model is on the test data. So I would like to show again a small, I can say a video or an image. So in the supervised learning, the baby will have already understood or seen the image of an apple or banana. So the parent would have told that this red color and this more or less the circular one is an apple, spherical one is an apple, and this the lengthy but yellow in color is a banana. So the baby would have learned this by color and shape that this is an apple. But given such a data like this, it's a lengthy but red in color. How does the baby respond to this? So this is what actually learning helps to identify this. Machine learning model helps to identify this. So for an unknown, unseen data, how does the baby recognizes this? So that is what the machine learning model does. And here comes the picture of generalization. Okay. So if your model is not generalized, so in such cases that model will fail to respond that this is banana. But if your model is overfit, that means it could recognize only those models, those samples that was given earlier in the training samples for the seen data set, the known data set, so it could respond well. Had it been an yellow color lengthy banana, so it can say that it's banana, otherwise it cannot respond well. So that is the overfitting model does. So there's a lot of difference between overfitting, underfitting, and the generalization of learning. So all it comes during the learning phase. I'll explain in detail later. Now this is an example for an unsupervised learning. So here there is no label that this is dog, this is cat, that is not given. Just by grouping based on the similarity, how tall it is, and so based on the features, how tall, whether it is fluffy or fat or thin or lean, short or tall. So based on this, the baby can group all the taller ones into one group, all the smaller ones into another group. Thereby, it recognizes that the taller ones of same category and the smaller ones or the shorter ones are of same category.
Hello, excuse me, ma'am. You are displaying code, ma'am. Actually, you are not showing the PPT. Actually, you are displaying code. You are having code for splitting data. The code has been displayed here.
Oh, so
You check
this video is not given.
Okay.
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 Okay. Anyway, I'm going to come back to this slide. Okay. Now, so we know what is supervised learning and what is unsupervised learning is all about. Sorry for that you could not see the video clips of supervised and unsupervised learning. Now, because now we are running short of time, I try to hurry up as much as possible. Now it's already 11:30, only 1 hour to go. Okay, so coming to this supervised learning model, how to fit this supervised learning model. Before we go for this, let us try to understand what we should do. So I'll just come to this slide later after explaining about this. So I was talking about this underfitting, appropriate fitting, and overfitting. So underfitting will happen if the training is not proper, when the machine learning model is not made enough to learn on the data. That is, I mean, the number of iterations, the complexity of the model that you generate, or when your sample is not sufficient. On both of these two cases, underfitting will happen. So you don't train sufficiently, or you don't give a sufficient training samples. On both the cases, this underfitting will happen. And for an overfitting, so you train too much. In such scenarios, such overfitting will happen. See, for example, if you are preparing for your exam, so if you read the same page again and again for 100 times, what will happen? You tend to memorize the pattern rather than analyzing or correlating the terms or the topics in that page. Rather than that, you try to memorize the content of that page if you read too much. So overfitting will happen. So what is the consequence of underfitting and overfitting? So the consequence of underfitting is, so for an sample, it will not respond well either during the training phase or during the testing phase. On both the cases, the error will be more. For overfitting, the training phase will be too good because it has trained too much that it responds well. It even gives 100% accurate during the training time. I'm just exaggerating, but still it gives a very good performance during the training phase. But for the case when your testing sample, that means unknown data is given, then it fails to recognize that unknown pattern. So that will not be, it will not be good in recognizing that pattern, and that is what is underfitting. So the error during the testing phase will be more, and the error during the training phase will be very less, and that is what is the overfitting. Now, appropriate fitting is you train sufficiently and give sufficient model for sufficient sample for the model to understand from the pattern, and that is what is appropriate fitting. Now, coming to this, I meant that we have training and testing. Testing is for the unknown data set, predicting for the unknown data set. So now we are going to divide the data into two things. One is the training set and the test set. So we are going to make the model to learn from the training set, and we are going to test how good the performance, how good the learning has happened from the test set. So here, so there are different ways of doing this. One is training, testing, and the other one is validation set. And this validation set is again, as like you have a training set, you also have a validation set. And this validation set is used for fine-tuning the parameters, estimating the parameters or fine-tuning the parameters. For those purposes, this validation set will be used. Or otherwise, see, the simplest of all is you just divide into training and testing, and make your model to train on the training set and test on the testing set. So the one other way of doing is cross validation. So what is this cross validation is about? So that is, the given sample will be divided into n fold. Here it is given as 5-fold. So the data is divided into 5 chunks here, and every time it takes one chunk for testing, the remaining other chunks of data as training. So it is alternatively the training chunks will be taken. So first time fold 1, second time it's fold 2, third time 3, fourth time 4, and fifth time 5. So whereas the other green ones are taken for the training phase at every time. And the average result of all this is considered as the final result of the model. And this is proved to be the good method of evaluating your model, how good the learning has happened. So for this, the training covers all samples. Testing is also covered by all the samples. Okay, so on due course of time, every sample is will be there in the training, and every sample will be there in the testing set. So that is why this is more advantageous than the other way of evaluating the model. So that is called cross validation. Now coming to the code that I have shown you. So, yes. So this is the code written in Python, and this uses scikit-learn package in the Python. This used to split the data set into train set and test set, and in the percentage of 80-20, 80% training and 20% testing. So it can be 70-30 or 80-20. So there is no hard and fast rule to say which percentage is ideal. It can be anything. You can make trial and error. It depends on the model, and it depends on the data set that you use. Now this X train will have the attributes of the training set, and Y train will have the testing labels, class labels on the training set. And X test has the attributes on the test set, and Y test has the labels of the test set. Now, coming to this is for the cross validation. I don't want to make it as 80-20. I want to go for cross validation. That is 10-fold cross validation. This is the code for that. So for this, again, the package cross validation, which is available in sklearn package. Here, this method cross validation k-fold is used, where you need to pass these parameters. That is, what is the data set that you are using? How many folds are you going to give? Are you giving any significance for the indices, the index of the data instances? So this is for cross validation. So now, so the first model of this supervised learning, what we are going to discuss is K nearest neighborhood model. And this is the simplest of all model in the machine learning. So the whoever is doing it for the first time can start with this K nearest neighborhood. So it is amazing that it was introduced in the year 1950. It is more than 70 years that it was introduced, and it is being used even now Even now in the literature, in the journals, you can find this K nearest neighborhood being used. So I'm just amazed by this author, Thomas Pugger, who has introduced this algorithm. I'm just amazed about his the simplest way of finding solution to the problem. So this is the simplest model of all. This is called as the lazy learner. Before proceeding further about the Skane-Gerst neighborhood model, I would like to just give in detail about this professor. This professor Thomas Coward was an electrical engineer and a statistician at the Stanford University. He has studied in Stanford University and MIT. He is an information theorist in its domain, and he has proposed this K nearest neighborhood in the year 1950. Out of all this is very simple model. Now, this K nearest neighborhood can be applied for classification as well as for regression. So we call this model as a lazy learner model. Why? Because so it doesn't involve much of training phase. There is no training phase there. So the training or the learning happens only when you give your test case. After then the learning happens. So whereas in other models, we will learn first, we will train the model first, and then we test. But here, so the learning will happen only when you start giving your test samples. So it works like the way the proverb says, tell me your friend, I will tell you who you are. So that means your behavior, your likelihoodness, and whatever you like, whatever you are interested, will have a match, more or less similarity with your friend. No? So the same way it is. So given a test sample, it tries to find out the closest pattern for the test sample and picks up the suitable answer for the test model from the nearest samples from the training set. So here the black colored one, so the black colored dot is the test set, and the other dots that you see as orange and red are the training samples. Now from this black colored dot, find out the most closest pattern. So here you can use K closest pattern. That is what is this K nearest neighbor. Choose the K nearest neighbor. So say suppose I am choosing 1, 2, and 3 nearest neighbor. So out of these 3 nearest neighbor, what is the class label of all these neighbors? Go for a voting, and then finally decide whichever has the highest voting. You can set that is the class label for this test sample. So here is an example. This black color one is the test sample, and for this the 3 closest pattern for this test sample is taken. So where there is 2 red and 1 green. So here if you apply voting, the majority will be the red because it has the 2 count, and the minority is the green which has 1 count. So what could be the color of this black dot? This unknown dot will have the color as red because the majority is red in the closest circle. So similarly, this is for 7 points, K nearest neighborhood of K equal to 7. So in this case, so what is the majority? The majority is the green one. Sorry that it is written here as blue. So it's green. Green is the majority. So here the dot, this test dot will take the color as green. So this is how the label assignment of K nearest neighborhood is done. So there is no much training phase here. Now the same thing is explained with an example. So you have some sort of data. So the big tip is the class label, whether the person will give the tip to the waiter or not, yes or no. So what are the factors that decides this tip? That is food, chat, whether it is fast, served fast, quick, price, whether it's a bar or not. So you have some values to this. So these values will help us to determine the class label of the unknown data, whether to be put into the category yes or no, whether he will get a tip or not. So given an example, like these are the attributes: food is great, and chat is no, fast is no, price is normal, it is not a bar. In that case, whether the person will give a tip to the waiter or not. So here, out of this, if you take all these data into two data into consideration, k is equal to 2. So the two closest number, the first one is number 2. So this is the closest pair for this test sample. Great, great, there is a match. No, no, yes, there is a match. No and yes, here is a mismatch. Normal, normal, yes, there is a match. No and no, yes, there is a match. There is one mismatch and 4 matches, which gives the class label as yes. And there's an again second case, that means the second closest pair for this test, that is number 1 here, this instance 1. So here it has 2 mismatch and 3 matches, which gives the class label yes. So when the food is great, chat is no, fast no, price is normal, and it is not a bar, still the person will get a tip, because it gives the result yes according to this k nearest neighborhood, where k is equal to 2. So here is another example where there are situations that you may get yes, no and yes, like this. No? So you get 50-50 percentage. So this can be avoided when you suitably choose your k, not k to be not too small or too large. In such a situation, you can avoid this. Having occurred this situation of 50-50, so that means your learner is weak. So points to be remembered. So what you should be careful in applying this model. So you should be very careful in deciding the factor k. First of all, this k nearest neighborhood is not suitable for large scale data set. And the second important point is the k value that you choose plays a very important role in the better learning of this model. So when your k is too small, so the structure is very close to finer structure, so it is more like overfitting. So for an unknown sample, it will not perform well. When your k is too large, and it will be more like your data set, there also learning will not happen. So it is like 50-50 chance. So you should give an optimal number of k. Just by trial and error we have to give. Okay. Yes. So there is another approach to improve it. That is, you assign weightage to the attributes differently. Also remove the irrelevant attributes from the data set. So these are the attributes. Suppose if some of the attributes doesn't contribute to this big tip, that means the class label, you can eliminate that. So you make your data set very compact, precise, so that there is no ambiguity or misleading factors here. So that way you can improve the performance of the model, and also you can assign different weightage for each of these attributes. Say I can give more weightage for the taste, how good or bad the food is, and what is the price. So you can assign some weightage to the attribute and choose the right k value. So by this way you can improve the performance of this KNN. So some of the applications of KNN is text mining, weather prediction, mapping the land cover and land usage from the satellite image, finance modeling, bankruptcies, money laundering analysis, credit rating. These are few applications where KNN can be applied. This is not limited to this. There are many such applications. To name few, I have written this. Now, the next model under supervised learning is decision tree. So decision tree was introduced in the year 1970s. That is 20 years after KNN. So that means this model is again a very popular model. It's being used even these days. Of course, there are a lot of variants of this decision tree are available, and this is even popularly used these days, even still. So even after 50 years, and this was introduced by J. Ross Quinlan, and this is a very good approach, I could say. And to give few information about this Professor Quinlan, so he is a computer science engineer and researcher in the field of data mining. His education was in the University of Washington and Sydney. Okay, coming back to decision tree. Decision tree is the most powerful and a popular tool that is used for classification and prediction. So I can say regression. Okay, so decision tree is like a flow chart. It's like a graph where it has some branching factors there, and there were many internal nodes and the leaf nodes. And we construct this tree from the given data set, and we traverse across the tree for the test set to know what is the class label of this. And the test label is understood from the terminal node or otherwise the leaf node of the tree. So how to construct the tree? So to construct the tree, so that means the data will be partitioned into different nodes, and each nodes will be further partitioned into further different nodes, and likewise this branching keeps going. It's like a tree. From the root, it's split. The data will be split, and from the every split, it is further split. So it goes like this, and this splitting is done based on selecting a particular attribute for splitting, and the values of the attribute will decide how we want to split, whether it is going to split into 2 branches or 4 branches. That is decided based on the splitting attribute. Now the question is how to choose the splitting attribute. For this we will be using some statistical measures like information gain, gain ratio, gain index. These are some of the statistical measures which tells how good that attribute can give information. When selected, it can classify better. Say for example, if I choose attribute say age, how good an attribute age can give a better classification. So that is captured using the statistics like this, statistical measures like this, information gain ratio, and Gini index, and each one of it has its own merits and demerits. Since lack of time, I'm not explaining all these formula, I'm just skipping it further. So this is an example of a decision tree, how it looks like. So now I want to decide whether I have to go out or not. So how do I decide? From the previous sample, there are attributes like outlook, whether it is rainy, windy or cloudy, or whether my friends are busy or not. So these are the factors that is going to decide whether I'm going to go out or not. Now, so what should I do? If I feel like yes, I want to go out, straight away you can go out. Or if you have a second thought, you want the other factors into consideration to decide whether to go out or not. So for that, first you will be checking the climate, whether it is a sunny, whether it is cloudy, or whether it is raining. So if it is a sunny, yes, go to beach. If it is cloudy, or you can go for a running or walking. If it is a rainy, you check whether your friends are busy or not. If your friends are busy, you better stay home, or otherwise you join your friends and go for enjoy a movie. So this is how it is. Now the question is, why should I choose Outlook? Why not it be a friends here? Now that is where the statistical measures plays the role. So these measures gives the value how good it is, whether you have to choose attribute or friends busy. So which will be more appropriate so that your decision will be good, and that is decided by the statistical measures, right? So every partition, so here there will be a set of data. All of these data end up saying that, so you go out. So here you have set of data where these data at this partition will have go to beach, go to running, stay home, or go to movie. So that can be further now partitioned into, based on the outlook, we can further partition this. Likewise, it keeps growing, and that is what the decision tree is all about. Now, so the very important, now we have understood what is decision tree and how to construct the decision tree. Now, the very important point in the decision tree is, just by constructing the decision tree, we cannot get a good solution. It will not give you a best solution. So we have to consider certain factors. First, whether the tree is a compact tree, whether the tree is not ambiguous. So if the tree is ambiguous, if the tree is large, so in such cases, it will definitely mislead the result, and the accuracy or the performance of the tree will be poor. So in order to improve the performance of the tree, we have to prune the tree. We have to cut the branches, whichever that is ambiguous, whichever that is degrading the performance, we have to cut down the tree. And that will reduce the size of the tree, thereby it improves the tree, reduces the ambiguity, it will generate a small size, compact, better tree, so that our results will be better. Now, the pruning can be categorized in two ways. One is pre-pruning and post-pruning. Pre-pruning is while you are developing the tree itself, you can decide whether to explore this branch or not, whether to expand that branch or not. So that can be decided based on certain measures, again a statistical measures, to decide whether to cut down there itself or to grow the tree further. That is pre-pruning. And post-pruning is you make the tree to grow completely, and then do some analysis or evaluate the performance of each of these nodes and decide where to cut, which sub part of the tree to be cut. So that is post pruning. So here there are two popular post pruning method here. One is reduced error pruning, and next one is cost complexity pruning. So the reduced error pruning is the simplest of all. So what it does is, you start with the leaf nodes, and each of the leaf node is replaced with the most popular class. So you just check the leaf node and replace the leaf node with the popular class. So thereby you keep making the non leaf node just one level above the leaf node. You replace the majority of the class in the leaf node to that node and cut the leaf. So that way you can do it. So replace the leaf node with the start from the leaf node and replace each node by replacing the most popular class of the leaf node. So then evaluate this. So which of this leaf node, reduced leaf node, gives the performance, better performance? So every time whenever you make such a change, you observe which of this change is good. So then you note down the leaf, whichever that is truncated, that gives the better result. That change alone is kept. Now such that leaf node is truncated, right? So this way of pruning is called the reduced error pruning. Okay, so this is the simplest and the speed the fast pruning method, easy to implement. Find the sum of errors over the entire subtree. Also calculate the error on same example if converted to a leaf with the majority class label. So you understand whichever that is better, you replace that, you truncate that leaf node. So that you iterate it for every node, and then finally find out the best average result. So that is reduced error pruning. And the next one is the cost complex. This is an example just to show. So now, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or the nodes. Here the nodes 4, 5, 7, 8, 10, 11 are the leaf nodes, and these are the non-leaf nodes, the ones.
பண்ணுங்க கிளிக் பண்ணுங்க
கிளிக் பண்ணிட்டேன் நம்ம
1 இயர்க்குள்ளன்னு பாரு எங்க இருக்குன்னு
நேக்குள்ள சொல்றியா இன்க்ளூடிங் 1 இயர் 1 இயர் 1 இயர் அட்ரஸ் கோடு லைன்க்கு அதே அட்ரஸா டாடி உங்களுக்கு என்ன மெசேஜ் வந்து
உடம்பு ஒரு 5 நிமிஷம் உட்கார முடியல
வந்தா தானே நான்
க்ளீன் அடி டைப் பண்ண வரும் பாரு
எலிஜிபிலிட்டி இல்ல ஆப்ஷன் இது வந்து வேற ஃபாண்ட் இதுல வந்து வேற இது இருக்கு
அது எப்படி நான்
இது வந்து விண்டோஸ் இது மேக் டாடி மேக்ல எப்பவுமே நம்ம விண்டோஸ்ல இருக்கிற ஆப்ஷன்ஸ் இருக்காது ஏமாந்து மொத்தத்தையும் முடிச்சிட்டேன் நான் முடிச்சிட்டு கூட ஓபன் ஆக மாட்டேங்குது நான் என்ன பண்றது ஐயோ select items children of ex-servicemen no தானே Tamil origin from Andaman and Nicobar Island yes or no வா no NCC or A certificate holder no தானே உடனே application approach அதான் கேரேஜ் ரெஜிஸ்டர் நம்பரா
ஏமா இது வந்து ப்ராப்ளம் ஆகுது நெட்டு வேணாமா
வேற யூஸ் பண்ணிருக்கா
விடுமா இப்போ என்ன யூஸ் பண்ணுவோம்
இப்படி என்ன பண்ணிட்டோம்
வெளியில் வந்து உள்ள வந்து பட்டு என்ன நீ மட்டும் தனியாக விளையாடிக்கணும் சரவணன் சார் எங்களை கொஞ்சம் அட்மிட் பண்ணுங்களா? முத்துரங்கம் ஃபிசிக்ஸ்ன்னு வந்துட்டு இருக்கோம் பாரு, 19 அட்மிட் பண்ணுங்களா? இல்லை 97 தான் வரும் ஒன்றும் ப்ராப்ளம். ஏன்னா யாரோ எந்த வெளியில் வந்துடுச்சா, அதனால் ஃபாலோ பண்ண முடியல. கட் ஆகலை, யூடியூப் போயின்னு தான் இருக்குன்னு நினைக்கிறேன். ஆமாம், யூடியூப் கட் ஆகிடுச்சு. யாரோ எக்ஸ்ட்ரா வந்துட்டுக்கிறாங்க உள்ள.
What could be the center point or the centroid or so-called the representative for each of these group, and that is called the centroid. The representative for all of these K groups are called the centroids. So then centroids are chosen. So from this centroids, that is representatives or the seed points, we find out, we apply some similarity measure to find out how the data points are similar to that of the center points, the centroids. So whichever data points that is more similar to the centroid, we will put it into that group. Likewise, every data will be just compared. So say suppose this is the two groups that we want to form, red and green. So let us consider this data, green data. So we will find out the distance between this green data to X and green data to blue X, and whichever cluster it is closer to, so we will put it into that cluster. So this dot is closer to this X, so therefore red X, so therefore we will put it into the red group. So this data is closer to blue group, so we will put it into the blue group. Likewise, we will form the groups based on the assignment of every data points to the cluster based on the similarity between the data points to the closest centroid. Now, so how do we check how good or bad is the performance of the cluster? And that can be done by this objective function. That is, this is the difference between the object to that of the centroid, and if suppose you are assigning some weightage for this, that is the weightage here. So now I can simply say that the overall average cluster average distance between every data point to every other cluster, it can be the average distance or it can be the sum of all the distances between every data points to the cluster will be the objective function, and this objective function will be minimized. So over a iteration, the distances between the object and the centroid will be reduced, because the centroids, once groups are formed, the centroids are reassigned and placed such a way that it is closer to all the data points. Okay, so the centroids is reassigned, and then the data reassignment is done again, refix the centroid. Likewise, it keeps going. So now the centroid will be in the mid of this cluster such a way that it is closer to every data points. Therefore, the distance between every data points to the centroid will be minimum, and the sum of all these distances will be minimum. Therefore, this J value will be reduced over every iteration, and this is called squared error. And if you take average of it, it is mean squared error, which is nothing but the average distance between every data points to that of its centroid. Okay, so here is an example. So for data set, we are trying to form clusters. So randomly choose some two data points in the cluster and find out the distance. Based on the distance, the closer the distance, place that object into the respective cluster. So now so here, so this is the distance. So the first distance, the object 1 to cluster 1 is 0, so it belongs to the first cluster. And here the object 2 is closer to first cluster compared to the second cluster, therefore it belongs to group 1. So this compared to this, it is closer to the second cluster for object 3. For object 4, it is closer to second cluster, therefore object C and D are placed in the second cluster, A and B are placed in the first cluster. So the centroids are reassigned and the cluster is again constructed. So likewise, it keeps going. Coming to the strength of it, so again, as like KNN, K means is the most simplest of all clustering algorithm. It is easy to implement, easy to understand, and for this first we need to find out what is the K value and what is the weaknesses. So weaknesses is it is unstable because it depends on the initial centroid value what you fix, and it is sensitive to noise and outliers, and you have to determine the k value, the proper k value. And for this there is one approach called elbow method, which performs a trial and error method of different k values and measure the performance of the cluster and plot it and find out the stability for the k and fix that k. And that is one way of choosing the k value. So determining the k value is very important, or otherwise your results may be weird. And it is suitable only for spherical and elliptical clusters, which is in the form of a circle and oval cluster with 2 dimensions or 3 dimensions. It is not suitable for irregular structures like this. So in such case, Kn is not the right choice. And this diagram shows that how the performance is worse in case of noisy data. Some of the applications is it is used for document classification, crime detection, fraud detection, cyber profiling, automatic messaging, cluster segmentation. I'm just skipping all this. Okay. So coming to clustering, we have applied this clustering using the nutrosophic fuzzy hierarchical clustering for the dengue analysis in Sri Lanka. So this you can observe that this is the dendrogram. That means it shows how the clustering is happened for every instances. And the number of clusters we have chosen is green, yellow and red 3 clusters. This is observed for a period of I think we have done for 4 years, from 2015 to 19. This paper is again published. And to conclude, so ML can be applied to any real world application which requires analytics. It can recognize the patterns through classification, clustering and association between the objects. It can be applied for a small to a high-end applications. That means from a handheld devices to a large-scale larger devices. It is suitable to handle medium and larger scale data set. If the data set is too small, statistical measures is sufficient to get inferences out of it. And for medium and large scale data set, yes, machine learning model is most appropriate. And for large scale data set, deep learning is the most suitable model for it. And applications can gain knowledge from the current and past data history. It is used for recommendation and decision making. So currently I could say there are no field without ML. ML is being used everywhere. And these are the few references. The seminal papers of K-nearest neighborhood, decision tree, then K-means, hierarchical clustering. These are few base papers which was done long back. So thank you for your patience listening. I'm interested to take queries if any.
Ma'am, there is a question from audience, ma'am.
Yes.
Hello. What is the difference between GPU and CPU, ma'am?
GPU, see, I'm not good at the hardware side, but to my knowledge, GPUs are more powerful. It is have high-end processors which has higher computing power, and it is more suitable for gaming and where it involves a lot of image and video analysis. So basically it has a high-end computing. So it can be used when you are using a large scale data set, you can use those GPUs.
Okay. There was another question, ma'am.
Yes.
Is it deep learning needs cloud computing or cloud server, or machine learning can be done only in the desktop machine?
Machine learning yes sir, machine learning can be done in the desktop machine itself. Even deep learning can be done in the desktop with the CPU, provided your sample is too less. That means suppose you want to explore on the data set like iris and then like whatever wine data set, the one that has very minimal number of instances, then you can use CPU, you can use desktop even for deep learning. So that trial and error you can do. But these days there are free cloud platforms available. If you want to explore, it provides up to few GBs that you can use free cloud sources for executing deep learning models with the higher large scale data set.
In deep learning, ma'am, you are using hyperparameters. If hyperparameters are used, the data will be very large. How it can be
No,
processed?
yeah, no. See, when we use deep learning on the larger data set, see, deep learning itself has, I could say, it's a high, very bulk as a model. It has too many neurons, too many connections between the neurons, too many computations. Irrespective of all that, we have different parameters that is mandatory for this. I can tell you that this hyperparameter in fact will boost your performance way better because there are dropouts. You can drop out certain nodes which doesn't contribute much, which doesn't make your model overfit, which doesn't eat up your computation. You can reduce it. And similarly, there are certain parameters where you can enhance the performance, your learning capabilities. So hyperparameters are required. I cannot say that it is because of hyperparameter it increases the computation. It is other way around. Because of hyperparameter, we can make an effective use of computing.
Thank you, ma'am. I think there is no more questions. It is time for voter thanks. Honorable Principal, respected HOD, most valued invited guest, and all the participants. No duty is most urgent than that of returning thanks. It is my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of Computer Science Department and the entire team of MGSC and my own behalf, extend very hearty vote of thanks to one and all today. I may like to express my sincere thanks to Professor S. Marimuthu, Principal, MGSC, for giving an excellent support and encouragement to conduct this webinar. Thank you, sir. Next, I would like to take this opportunity to place on record our hearty thanks to our HOD, Professor I. Annette Regina, for her perfect logistic support and guidance she has extended to all of us in organizing this webinar. I must mention deep sense of appreciation to Dr. J. Anuradha, Associate Professor, School of IT, VIT, for giving an excellent coverage on machine learning. We are all inspired by your grand words. Thank you, madam. I also thank my department faculties for their cooperation in the organization of webinar. Our special thanks goes to Dr. P. Srinivaskumaran, head of the Department of Physics, MGSE, for his involvement and his willingness to take the part of the organization of webinar, which helps to complete this task beyond the comfort zones. Thank you, Professor. Finally, I would like to thank all the participants for spending your valuable time by actively participating in this webinar and gaining some knowledge during this pandemic time. With all these warm words, I thank one and all in this group and move to the end of the day's webinar. Thank you all. Thank you.
Thank you, sir.
Thank you, Dr. Anuradha, ma'am. Thank you very much.
Oh, welcome, sir. Thank you. The pleasure is mine. I could try to do whatever brief I could give within 2
it was
hours.
very nice and very hard topic, it is very nice. Kindly express our thanks to Dr. Anbarsi also.
Yeah, sure, sir.
Thank you
Thank
for
you.
showing.
Thank you, ma'am.
Thank you.
One more announcement to the participant. Actually, we are having one more webinar on 3rd 3/7/2020, that is 11 a.m. We are conducting another webinar on deep learning using Keras and tensors. If you are interested, you can register the link. I send the registration link also. Thank you. Okay, we can close the session now. Thank you. Thank you all.
ஃபைசல் க்ளோஸ் பண்ணிடலாமா? முடிச்சிட்டாங்க ஃபைசல். நீ இருக்கியா வரையா லைன்ல? நான் ஒரு அப்ளிகேஷன் எடுத்து பாரு, எப்படி இருக்குன்னு பாரு. ஓப்பன் பண்ணியிருக்கேன் பாரு, தெரியுதா? ரைட், அது மாதிரி ஒரு 4 பண்ணி விடுங்கப்பா. பண்றீங்களா நீங்க? ரைட். இப்போ நியூக்கு வந்து எப்படி போனோம்? இப்போ இது வெளில வந்துடணுமா? லாக் அவுட்டு. இப்போ இதெல்லாம் கொடுத்து ஓபிஎஸ்ல க்ளோஸ் பண்ணிட்டுமா?